Hello, welcome to Kira Tech Hub. My name is Pauline Namokira, and in this video, basically, part 3 of our really short series on observing and diagnosing your network on AWS. We got started with the VPC Network Access Analyzer. We moved on to part 2, VPC Reachability Analyzer. And now in this video, we're going to zoom out and look at the big picture, the AWS Network Manager, which will help us to visualize, manage, and troubleshoot complex networks that spans, multiple VPCs, multiple accounts, and even on-prem location in that case. So why the network manager first exists? Okay, so the core problem, when networks are small, it's easy to understand what's connected to what, okay? But as our environments grow, we have no single console view which shows the full story. So that is where the network manager comes in. It shows this visibility gap whereby uh, our troubleshooting is going to become faster with the network manager. We are going to have visibility. We can see our network across all these sections. So what the network manager basically does, you can think of it as a network operations dashboard. So it's not a firewall, it's not a routing service by itself. It just gives us a global view of our network, centralizes all our attachments, our transit gateway and routing. And because you have this bigger picture, you are able to troubleshoot connectivity and routing issues. Now, how it fits to the other 3 tools that we mentioned about. So it does not replace these tools, it just connects the dots. For example, with the network access analyzer, we are talking about who could access what. With reachability analyzer, we are answering the question, why can't this connect? Now, the network manager gives us a global view, a global network. How is this network structured and routed? So, and when I talk about a global network, this is not a physical network, okay? I'm not talking about the AWS global infrastructure. So it's not a physical network or so. It's just a management construct that helps us see us everything in one space, as I have mentioned. So in our hands-on exercise, we'll do different parts of this. But before we get started, we have to set up our architecture. Don't be alarmed. So this is the architecture we are basically going to deal with. And I have this cloud formation template that is a mirror of the architecture diagram that I have shown you. So this cloud formation template, it's not really the best because we have basically had coded some values, which basically means this template is going to work in the US East 1 region. We could do better, yeah, and make it more dynamic, okay? But just for the demo purposes, I mean, yeah, you can forgive me for that. And I'll share a link on where to get this template. It's just part of a AWS Workshop Studio. So it has a lot of parameters and lots of resources, which are basically this. So what I'm going to do is use CloudFormation to launch this template. And while it launches, I'm going to come back and try explain this architecture just to save on time over here. Okay, so CloudFormation, where are you? Okay, so let's create a stack with new resources. I'm gonna choose an existing template, which is downloaded, and I'll share the link on the description, okay? Okay, stack details, Kira, network stack, I think that's cool. And the parameters, so availability is on 1A, 1B, the instance type for our web server. We'll see all this in a moment. And I think I don't need anything much. I acknowledge that CloudFormation is going to create some resources for me. Next, and submit. Okay, so while the CloudFormation template is creating our resources, which will take some time, let's just have an overview of some of the resources that we're trying to create in this case. So if we start this architecture, the big picture of what this architecture is doing. So as you can see, this architecture is using multiple VPCs. We have the production VPC. Maybe I need to change the color of the pen. So we have the production VPC, inspection VPC, central egress, and dev VPC. All these VPCs are connected together by the AWS Transit Gateway to just enforce some strong network security control. The main idea over here is our workloads live in separate VPCs. All traffic is centrally inspected from the inspection VPC, and internet access is tightly controlled from this architecture. Nothing talks directly to the internet unless it's explicitly allowed and inspected in this case. So diving in a little bit deeper, we can see on our left side, we do have the production VPC over here and the development VPC. These VPCs contain our application workloads, each VPC. So we can see we have some EC2 instances in this case. What you can realize is these VPCs do not have an internet gateway. So these are private subnets only. Both VPCs send all non-local traffic. So you can see the route tables. Non-local traffic, you're saying, do not send to the internet gateway, but to the transit gateway. And that means that the development and production environment are isolated. They don't have direct internet access, and there is no accidental cross-environment communication in that case. Now, moving on to the transit gateway at the center. So the transit gateway is the traffic director in this case. It sits in the middle and connects all the 4 VPCs in this case. And it's using different route tables. You can see each VPC has its own route table, which control how the VPCs can talk to each other, where the traffic is sent next, which paths are allowed, which paths are blocked in that case. So this is where the network segmentation happens. For example, as you can see, from these route tables, all the non-local traffic is being sent to the transit gateway. But then, again from here, for the prod and the dev route tables, all non-local traffic after coming here is basically redirected for inspection within the inspection VPC. So that is basically it, and more rules again. For the inspection VPC on the top right, as we can see, all traffic is going to pass through here before going anywhere else. What we can see over here, we have this firewall endpoint. So the inspection VPC actually contains the network firewall, AWS Network Firewall. It has some firewall endpoints and also a transit gateway attachment. Any traffic that leaves production or dev, goes to the internet or process environment must pass through this firewall first. And what we're trying to ensure in this case is we do have some centralized security policy enforcement, no firewalls bypass any paths, and there is consistent inspection for all traffic going through our environment. And the other VPC over here, we have the central egress VPC. And what you can notice over here is, where's that internet gateway? Somewhere. NAT. Okay. So here in our routes, maybe it's, oh, here. Oh God, why would I not see that? So the internet gateway is here. So from what you can realize is, this is the only place where internet access exists. So it's the only VPC with a NAT gateway. And we know the purpose of the NAT gateway being enabling, by textbook definition, enabling our resources in the private subnets to access the internet. And the NAT gateway only allows egress, traffic. So no traffic can be literally initiated from the internet. So we do see this is the only VPC with the NAT gateway and the internet gateway performing network address translation. So all outbound internet traffic comes from prod or dev VPC. They first go through, you can see the path, they first go through the inspection VPC, they go through the firewall, they reach the NAT gateway and exit via the internet gateway. So yeah, this design prevents direct internet access, makes outbound traffic observable, and also simplifies some sort of auditing in this case. Now, let's take a look at our CloudFormation stack and see if our resources are ready. Cool. Too much talking. create complete. And yeah, we have a couple of resources being created over here. We can see some security groups, the internet gateway attachments, the subnets for the central address, the dev resources. We have the transit gateway resources and associations being created, the inspection firewall resources as well. We had some databases in the prod environment, yeah, and so on. So these are the resources that are part of our architecture. The first part, we are going to be visualizing our network. So what you're trying to achieve in this case, let's see, instead of reading root tables and attachments manually, we want to create a visual map of how everything connects. So if we have a visual topology, it often reveals these issues that text-based configurations hide. So we are getting a better documentation in that case. And as I mentioned before, the network manager does not change routing, okay? And it does not manage any routing. It just shows you how your routing is organized. You're going to see your attachments, your VPCs, and the relationships between them. So let's take a look at that and see how it works. Okay, so under VPC, how to get here? Again, under VPC, it's still part of Network Manager. So you're going to click on that and it will take you back to this page. And then under connectivity, we can see global network. So you can click on that. And we go ahead, create a global network. I give it a name, Kira. Let's go with my name. Kira Global Network. Okay. Next. So I'll just uncheck that and create. Okay, so that's cool. It's created. And over here, I can see like I need to connect my transit gateway. So under the Kira Global Network, I'll go to transit gateways and register my transit gateway. Okay, so that is it. Okay, now it's available. So basically, I could click on it. I can view all the attachments and I can also have a view of the topology tree. So there I can see the VPCs and all the VPCs that are basically attached. You can see the VPC attachments and you can actually, go to the transit gateway network and visualize your network with a different view if you want to. So in the next section, I'm going to use something called the route analyzer to understand how routing works. So with the route analyzer, maybe we have a problem. Maybe traffic between dev and prod is failing and we need to understand why. The analyzer, the reachability analyzer will tell us something is blocked, okay? But the route analyzer will tell us, how the transit gateway routing decisions are being made in that case. So what the route analyzer in that case will tell us, it will be like, given these route tables, where does traffic actually go? That is what the route analyzer helps you. So you don't confuse that with the reachability analyzer. So it simulates the routing decisions inside the transit gateway. It explains the routes, black holes, missing routes, any attachment behaviors, and so on, why traffic is not flowing. Now, a black hole, something that we have mentioned. Black hole routes is traffic intentionally dropped. You specify that route as a black hole, let that traffic be blocked. Now, they are very powerful, but dangerous if they are misused. So these black hole routes are often used for isolation, and you'll see an example of that. The network manager will help us, understand them, make these black holes visible and explainable, okay? So because it can be accidental at some point. So let's go ahead and, take a look at that, see how we can use the route analyzer to validate the routing on our transit gateway. So before we continue, uh, just back to our architecture. Okay, so before we continue with this, we need to disassociate some rules that we have specified before from our network firewall policy. So we'll go to VPC, our network firewall. And then we are interested in the firewall policies. And I want to disassociate this. Okay. Now back to the route analyzer. Okay, so I'm interested in the transit gateway network that I created. And at the very end, so we can see the overview, we can see things like the geography of our resources, on-prem, any connectivity, any associations or what is not associated. But for me, everything is like in one geography, okay? In the US, it's one region. Okay, anyway, I'm interested in the route analyzer. So in this task, we are going to troubleshoot, the connectivity between the dev and our production VPC. Hence, that is what we'll have for the source and destination transit gateway attachment. So we are going to try and find the dev and production instance private IP addresses so we can use that. So I'll just go back to EC2. So we have the prod instance. Here's the private IP. So this will be for prod. And then this will be for dev. Okay. And I'll check this box, middle box appliance. So what is that about? Now, the middle box is when traffic passes through firewalls or is maybe an inspection appliance, we must tell AWS that this is expected behavior, okay? So the inspection VPC that we have as part of our architecture, that is going to introduce what we call a middle box because they have to be accounted for. Because if we are routing through an inspection firewall, that means that our routing behavior is going to be different. So that is why I'm checking that specific box, okay? So we have a middle box appliance as part of our architecture. And we go ahead and run the route analysis. So, okay, yeah, as you can see, the results available. We have a black hole route. And as I mentioned before, a black hole route is whereby traffic was intentionally dropped in that case. So back over here, and it's giving us the link to the root table where that issue is available. So let's go ahead and remove this black hole root in our transit gateway root table. So here it is. And we can see the roots. So what I'm gonna do for the roots is just edit the settings and allow to see these things like the root type. I think they're important, confirm. And now they're back. So as you can see, this second root to this specific VPC is a black hole root. So I'm going to remove that. Actions, delete static root, and then delete that root. So after I'm done, I can go back and rerun the root analysis. Refresh. Okay, so at least now we can see that the black hole root is gone. However, we still have the status not connected. Now, as I mentioned, as you can see over here, middle appliance is no. So since traffic between the dev and the prod VPC is inspected by the network firewall in our inspection VPC, that means that we'll need to enable a middle box appliance. So I'm gonna come here and change, and then I say, yes, the inspection VPC is basically has a middle box. And then we rerun. And now you can see that at this time, it will show that this is connected. The status is connected in both directions. So you can actually log into the servers and do a ping, and everything, yeah, is going to be okay. So here we have used the root analyzer to troubleshoot the connectivity between the prod and the dev VPC through the transit gateway and inspection VPC. So that's it. We have discussed the AWS Network Manager. We have seen the global networks under monitoring and troubleshooting. Part 2, we discussed the reachability analyzer, and part 1, we discussed the network access analyzer. So thank you for sticking around, and see you in the next one. Not forget to like, subscribe, and share. Bye bye.